Welcome to homework.
So let's draw the diagram for the pilot. We can say that this point would be the point mass of the pilot if we're treating the pilot as a point mass, which we are. Going straight down would be, of course, the mass times gravity, so this would be the weight of the pilot. At an angle here, this would be the net force. And then this resultant vector would actually be the force of the seat. So let's actually, we should have better placement. This would be force net. And then we have this angle here equaling 18 degrees. So this would apply to force net, and this dashed line represents the horizontal. So we can say that force net, this is also not drawn to scale, just to mention. So we can say that the force net would then be equal to mg plus the force of the seat, and this would equal the mass times the acceleration. We can say that the force of the seat then is going to be equal to the force net minus mg, and this would be equal to mass times acceleration minus mg. Now, at this point, we can solve for the force of the seat on the pilot using the components. So the force of x of the seat, or the force of the seat in the x direction, would be equal to the force net in the x direction. This is going to be equal to ma cosine of 18 degrees. We can solve, so this will be equal to 75 kilograms multiplied by 3.8 meters per second squared. The mass of the plane the acceleration of the plane will be equal to the acceleration of the pilot times cosine of 18 degrees. So we find that this is going to equal 271.1 newtons. And then we want to find the y component for the seat. This would be equal to mg plus force net in the y direction. This would be equal to the mass of the pilot, 75 kilograms. Times the acceleration, 9.80 meters per second squared. And then we can say plus the mass of the pilot times the acceleration of the system, 3.8 meters per second squared, times sine of 18 degrees. And so this is going to be equal to 823.2 newtons. And so if we wanted to find the magnitude of the seat, this would be equal to the square root of the sum of the squares. So 271.1 newtons, quantity squared, plus 823.2 newtons, quantity squared, all to the 1/2 power. This is giving us 867 newtons. So this would be the magnitude of the force of the seat on the pilot. The angle of this force would be theta equaling arctan of the y component, 823.2 newtons, divided by 271.1 newtons. This would be equal to 72 degrees. This would be above the positive x-axis. So essentially, if we wanted to represent this on the free body diagram that we just drew, we can go back and say that this angle here is, again, 72 degrees. So that's how we would resultant force. Essentially, the resultant force here would be the force of the cockpit seat on the pilot with a direction of 72 degrees above the horizontal. that is the end of the solution. Thank you for watching.